Okay, so distance part 2. So we've got this car. The driver says, I got to hit the brake. So they hit the brake, and now the car is drifting. Okay, now the car is sliding, and it has to stop. How far does it need to go in order to stop? We are going to use another equation. We're going to use an equation that uses acceleration. So it's going to be this. It's going to be VF equals VI squared plus 2A triangle X. All right. We're going to use this equation to solve for the distance the car's traveling as it drifts or slides. So Jimenez, we're in day 15, the folder called Extra Help, and then Distance Part 2. Let's go to Elijah. Elijah, what are we trying to solve here? What letter is the goal? V? VF. So VF is we have that at 0. So we don't need VF. It's either VI, A, or X. X. So we need to get X by itself. So everyone, let's solve for X. So the first step in these problems is going to be subtracting the VI. Okay. So I'm going to make it red. So I should see you writing. So I'm going to be calling on you next. Okay? So these VI squared cancels, but not here. Jimenez, what's left over after we combine this with this? Can you tell me what I should write? So the VF is on the left, and we did a minus VI squared to both sides. What's left over here on the left? Did VF get canceled out? The only thing that can cancel out VF is a minus VF. Did we do a minus VF? No. So we have to rewrite it. Everyone write VF and then minus VI2 equals, and then what's left over if we just subtracted VI2 from here? 2A triangle X. So you can see this document, Jimenez, on your computer. Does your computer work? Yeah, go to day 15, go to Extra Help, and then go to Distance Part 2, and then you won't have to keep checking this screen. All right, is X by itself? Jesus, is X by itself yet? No. So how do I cancel out the 2A so that X is by itself? If it's a square, but right now they're multiplying. So we're going to do the opposite of multiplication. We're going to divide. So everyone take your pencil, divide this whole side by 2A. And Carlos, tell me what's left over. VF minus VI squared over 2A equals triangle X. Okay. We're going to solve for this problem now. This is what we're going to use. This whole equation. All right, Caleb, are you catching up with us? Okay. Elijah, let's plug in our variables. What is VF? That's VI. VF. Yeah. 0. We're going to add that to VI squared. Now what's VI? 28. But don't forget to square. And I was supposed to minus. Make sure that is something you include. Okay. And tell me what I should plug in next, Elijah. All right. So A is what value? What's the number for A? Good, -6. And it's not just A by itself down here. It's 2A. So I'm going to put 2 and then put our -6. Elijah, what does a negative acceleration mean? Slowing down. Slowing down. Good. And that is our X. Carlos is doing the math. Carlos, what is 0 minus 28 squared? -784. I'm so glad he included the negative, because if he doesn't, he's going to get the opposite answer that we need. What's on the denominator? What's 2 times -6? Oh, what kind of mode is it in? Clear? And then when you do negative stuff, you have to use this one, not that one. So -6. -12 equals X. Elijah, bring us home. What's -784 divided by -12? Okay, explain what has to be done. How does he multiply and divide negative numbers? Jimenez, you knew that too? You knew that too? Okay, so now you both know. Negative is underneath 7. Yeah, divide it. Divided by -12. Tell me the whole thing. 65.3. And then what's after the 3? 3. So why didn't we round up and make it 3/4? The number when we round is what number? Anything that's 5 or higher. 5 or higher. So since you said it was a 3 after the second 3, we're not going to round. Okay, so this is our X. Jesus, Caleb, you're done writing. Which X did we just find? Now you have to guess because you missed the whole part 1. It's either XRT or XB that we just found.
XB.
Why? Because oh, you were here. Oh, you did come back. Okay, good. So we found XB. So let's put that into our picture. And we're not done yet. Why, Caleb, aren't we done yet? What? The goal is to see how far the car goes until it stops, right? Person's thinking, car's drifting, stop. So, what's my final answer? It's not 14 and it's not 65. What should we do? This much is 14 meters. This much is 65.32 meters. What should be our final answer? We're trying to find the total.
The total, yeah, that's what we're gonna have to. I wouldn't say subtract.
Subtract would make it smaller.
Yeah.
We want both of these combined.
So root or
root is undoing squares.
undoing squares.
Yeah. Do you agree with what he said?
What is it?
Why? Why do you think that? You need the whole thing together. Carlos sees that this is one big road. So the only way to get the whole road distance, you take the 14 we just found, you take the 65.32 we found. So put that in your calculator, and then we'll be done for the day. Yeah.
13.
Oh, okay. Let me finish here. Sorry.
Wait, I got 13. 14. How could you do 0.4? 33. 79.33.
That's correct.
That's the answer.
That's the answer. Well done. 79.33 is how far the car needs to travel to completely stop. That's really far. That's almost a football field. So our car must have gone really fast in order for the person to realize, oh, I got to stop. And then the car is finally stopping. Right? So that is our second physics problem that we have solved today. There's one more, but it's going to take probably another 25 minutes. And I don't want us to do half a problem and then just